Hello, this is Nicolas, the DeepChain lead at InstaDeep.
Hi, I'm Marcin. I'm bioinformatics lead at InstaDeep.
We are here at InstaDeep headquarters in London to tell you more about this exciting platform. So, what is DeepChain? DeepChain is our platform for protein design. Given a complex you are working on, DeepChain will deliver insights based on state-of-the-art biophysics and machine learning models. So what does DeepChain actually do? Well, DeepChain is essentially three things. It is a scorer mechanism. So we take simulations, we take neural networks trained on millions or billions of amino acids to give a score for a given pose or sequence. But it's also a very powerful optimizer. We use methods like reinforcement learning optimization or evolutionary algorithms to find the best mutation that optimizes your structure. And finally, it's a platform where you can really leverage the power and the insights of language models trained on millions and billions of proteins to help you with the protein design task.
There are plenty of methods available online to perform bioinformatics tasks. What sets DeepChain apart? Well, DeepChain is different from what you have seen so far. DeepChain has a first principles-based macromolecular simulator which uses not only biophysics but also augments it with state-of-the-art machine learning. It gives you a possibility for independent verification of your scientific hypothesis, and it gives you infinite expression capabilities that we'll talk about in just a moment. If I'm an experimentalist with no real computer science background, what benefit can I get from DeepChain? Well, you're in luck, because you're exactly the person that we designed DeepChain for. DeepChain allows you to tackle complex biological problems without having to know anything about optimization, simulations, machine learning. We make state-of-the-art tools available to you at the click of a button, with reasonable defaults in such a way that we know that the results that you get will be meaningful. And not only meaningful, they will be interpretable. They will inform your future experiments. And if you really are averse to computational methods, it's really a click and forget approach. And that will give you your next figure, next plot, next data set for the upcoming paper.
You can start uploading your PDB file. This can be a file available locally in your computer or any protein data bank ID available on PDB. And with that PDB file that would represent the complex, we can select some positions using DeepChain user interface and optimize them by the use of the AI designer. The AI designer will start replacing the residues in the selected positions until the binding stability or any criteria of your choice gets optimized. This is the magic of DeepChain. You are deciding your own criteria. But also, you can use the DeepChain playground. This is leveraging language models that can identify high-function regions in your protein just by looking at the protein sequence.
But what if I'm a computational biologist and I develop my own methods? Is DeepChain relevant to me? DeepChain has been developed for people like us. Not only it presents a simple user interface, but also it gives you an almost infinite customizability. You're able to develop your own software, your own scripts, your own methods using DeepChain, utilizing our fully free API. DeepChain is fully modular, and as such, if you want, you can replace any or every bit of the system with something that you have a trust in, something that is more suitable for your own purposes. Finally, DeepChain starts with a large ecosystem of apps that you develop and that then can be seamlessly integrated into DeepChain as a platform.
So, what are DeepChain apps? We have been talking about them. DeepChain apps is a collaborative framework that allows the user to train neural networks based on protein sequences. These neural networks can be either predictors or classifiers, and they become the scorers of DeepChain. So given a sequence, you can score things such as immunogenicity or toxicity of a sequence. So, in summary, we can take our own data, calculate the protein embeddings with the DeepChain, and use that to train a classifier or a predictor to use as an app. This app will give a score that can be used for an optimization run on DeepChain. So how can we build an app? Well, we got you covered here because we are open sourcing 3 repositories. Biotransformers, who make it very easy to work with these large language models. Biodatasets, a repository of protein sequence datasets together with its embeddings to make the training easier. And DeepChain apps, where we provide the templates that make creating an app very easy. To find out more, just go to our GitHub, DeepChain Bio. They are Apache licensed, so you can use them for anything you want, not just on DeepChain. We talked a lot about AI Designer, we talked a lot about language models available on DeepChain Playground, but DeepChain is more than that. There are different modules, such as the MD simulation module, where you can use GROMACS as a service. You upload your PDB structure, you set parameters such as temperature and duration of the simulation, and we will run it on our powerful NVIDIA A100 infrastructure to get the results back to you. Another important feature that we provide on DeepChain is Jupyter Notebooks hosted on DeepChain. So you can have all your data in the same place. Another important feature is the pattern search engine, where we can provide information about the IP on the sequence that DeepChain came up with.
But what if I don't do protein design? Should I care for DeepChain at all? Well, even though DeepChain has been developed as a protein design platform, it's not only one thing that it does. What we can do is we can do protein structure assessment. You can upload a PDB file, and it will tell you what's right and what's wrong about it using our own internal assessment methodology. You can, in turn, do modeling of SNPs. You can see which polymorphisms have a positive and negative effect on your structure. By default, in order to provide the best possible accuracy and performance trade-off in DeepChain, we focus on the amino acid-based systems. However, within the DeepChain app ecosystem, we're able to handle a vast array of computational biology tasks. And as our simulator is very much physics-based, we're able to accommodate anything that you may want to simulate. So does that mean that DeepChain performs docking? No, not really. However, if you do know how a complex is about to assemble, you can simulate docking using restraints. And if you don't know how your complex is to assemble, you can use our language models to predict the complex interfaces.
So why DeepChain? Well, we all know that protein design is a very complex problem, and it can be tackled from several angles. This is what we are trying to do on DeepChain. We are using state-of-the-art biophysics and thermodynamical models through simulation and energy potentials, but we are also leveraging cutting-edge AI, such as the transformers trained on millions of protein sequences. This conglomerate of techniques make DeepChain a very powerful tool, and we put it in your hands and accessible to the general biology community. We are very excited and we want to see it grow. We think it will grow with the user base and with your feedback. So we are very keen for you to use this platform that we are very excited at. So help us democratizing science and putting these very powerful tools in your hands. Join us at deepchain.bio. Remember that DeepChain is an evolving product, so we have things like docking and ab initio folding in our roadmap.
Thank you for your attention, and I hope that you enjoyed hearing about DeepChain as much as we enjoyed building it.
Yes, remember to check us out at deepchain.bio or at our GitHub open source repositories. I hope you enjoy the rest of ISMB.